Shake Table Lab by Cooper Powers and Eli Coffer. We put on the base of the building because we thought a base would give more attachment points between the building and the ground. We placed the outer struts as a basic frame between the base and the first floor. The first floor with a cross brace below it is vital to support the sandbags because without the cross brace, the first floor couldn't support as much weight. These braces support the weight transferred to the walls of the building. We placed braces on the second floor where we did so it could support more weight without buckling the straws. The whole building is 38 centimeters tall. The first floor is 13 by 21 centimeters. The second floor is 22 centimeters by 9 centimeters. During construction, we tested the strength and stability of our structure by putting 2 sandbags on each floor. Our strategy on the base was to wrap one long piece of tape around the straws and under the cardboard to ensure stability. The cross brace shown in the picture is our strongest part because it has no flaws and supports the top floor as well as the bottom. This cross brace is the weakest part of the building because when we put the sandbags on the building, this part threatened to collapse.
We chose to put the string in this location to make sure that the sandbags would not slide or fall off.
We used tape to connect the paper flooring with the first floor, to connect straws for cross braces, to connect the base to the cardboard, and many more ways. If we had 5 extra straws, we would place 1 straw in the middle perpendicular to the ground between the first floor and the ground. We would place the other 4 straws in an acute pyramid around the first straw.
Go.
This is the light duty, right?
Which one?
Yes, light duty.
What was the height?
37. No, it was 19 and
Building
18.
inspector?
It was 19 and 6.
1918.
Woo!
Oh, wait,
All right.
I guess Rocky 4 is gone.
Major with 3 sandbags on the bottom.
I'm such a good timer.
I know, you've only messed it up twice.
Because he said timer.
Alright, next one.
You're
On the bottom.
A rubber band.
Wait,
and,
this
I guess I'm sorry now.
our extra points.
Yeah, Aiden's cameraman.
Alright, good.
3, 2, 1, go. Oh, shoot. Kayla, you're going to go.
It's still sturdy.
My head's going to go to the top.
No, it's done. It's like about to fall.
What's our grade?
Oh,
shoot, straw filled.
These are our sensor readings while Mr. Clausette was shaking our tower. The x-axis is in green and goes back and forth. The y-axis is in orange and goes side to side. And the z-axis is in blue and is up and down motion. Hi, my name is Cooper Powers and this is my Shake Table Lab interview. My building supported 3 sandbags on the bottom and 2 sandbags on the top. When my building failed, 2 things happened. First of all, one of the cross braces got cut off near the base, so a little piece of the straw was still there, hanging, where the rest of the whole cross brace was swinging back and forth. And also, one of the other cross braces was bowing inward and outward repeatedly until finally the building fell one way. If I were to build the building again, I think I would fix these problems by putting down more tape and maybe using my string more wisely by also securing those 2 places down with string as well. Because in the end, our boxing ring didn't really help that much. What I learned about building strong earthquake-proof buildings was that you have to use cross braces so that the building won't bow inward or outward. This also helps stabilization, like the triangular shape of the building. What I liked about this project was the creativity you could use, and also building your own building, and learning about concepts of strengths of buildings and earthquakes. Thank you.
Hello, my name is Eli Coffer, and I'm doing the Shake Table Lab interview. Our building supported 3 sandbags on the bottom story and 2 sandbags on the top story. Our building ended up collapsing because I watched the video again in slow motion, and one of the struts bent, which caused a cross support to fall out, and then it just sort of collapsed down onto its side. If I was going to build it again, I'd probably give some more support and make sure that everything had some support both straw-wise and tape-wise, because other groups had a lot more tape used. I learned that triangles are a great way to support directional earthquakes. So that was how our cross struts were like that. So I learned that just straight up beams doesn't work very well. So you need triangular shapes to be better proofed against earthquakes. I really like this project because we were able to use learn about properties of earthquakes.